Morning, everybody. I'm going to show you some data for the accelerated motion lab of a car going down an incline. So this is a variation on a lab or activity I did last week. In this case, we're going to make measurements of how far a car travels and how much time it takes, and then from that you're going to figure out two things. You're going to determine the acceleration of the car along the ramp, and then once you have that acceleration, you're going to figure out where to place the car on the ramp such that when it gets to the bottom, it's going a prescribed speed. That speed will be on your lab, and then you're going to use that speed as part of your information to help you figure out that position as measured up from the bottom of the ramp. So let's turn to then the actual measurements. So I'm going to let the car roll down a ramp 5 or 6 times. You're going to time it. I will show you what the distance is traveled, and then the rest is just calculations and analysis. An important part of this lab will be propagation of error. There will be uncertainties in your distances and times, especially your times, so you have to show how that propagates through when you're calculating your uncertainty and acceleration, and ultimately even the uncertainty and velocity. Lastly, you're going to make a prediction of position so that's going a certain speed. Normally we would test that in class to see how accurate results are. I'm going to basically test it with the photo gate by releasing the car from various positions, and you match whatever position that I do to your prediction and then see how close the velocities really are. I'm going to choose positions based on what I expect the actual one to be plus a range above and below. We'll see how that works. So this is our setup. So I have the car sitting on the ramp, tape's just there to hold it, and it's going to roll the way down and hit that aluminum block at the bottom, which is at position 0. I will note where this is starting for each of the 6 or so trials, and then I will say 3, 2, 1, and then release or go, and that's when you know to start your timer. I will then follow the car down, and you know when to stop it, and repeat that 6 times. Okay, so let's start with the initial position. So I'm going to go based on the plunger right there, the tip of it, because that's what's going to hit the block below. It's at position 200. Now I don't know it's exactly there, so add an appropriate instrument uncertainty to the 200 centimeters. Okay, so let's get ready to release. 3, 2, 1, go. Okay, that was trial 1. Let's do trial 2. 3, 2, 1, go. It's nice the way that bounces back up. All right, third trial. 3, 2, 1, go. All right, hopefully you can hear that clearly. Fourth trial. 3, 2, 1, go. Okay, number 5. 3, 2, 1, go. Nice. I love this car. And the last one. It's trial 6. 3, 2, 1, go. Okay, so the next segment of the video will be based on the predictions of where to place the car. So let's be clear. The car starts here at 0. You're going to figure out how far we place it up the ramp such that when I release it, it's going to be going a certain speed, an instantaneous speed. This requires knowledge of not only how far it travels. You're going to predict that. You're not going to have any time. You don't know how much time it's going to travel. The times you just took are based on the 200 centimeters of distance of travel. So you're going to use your acceleration that you found in part 1 plus 2 other pieces of information that you know about the motion to help you figure out how far up the ramp it'll go. All right, good luck with that, and then we'll do the next segment in a few. All right, let's do our tests of our predictions. I'm going to release the car from 5 or 6 different positions at 10 centimeter intervals. You're going to match the position that comes closest to what you predicted. Now, if I'm going to start at 110 centimeters. If you predicted yours was like 98, you're going to have to make an adjustment. That 98 is going to be too low. If you predicted 115, you're going to take the halfway value between my tests for 110 and 120, and so on. So we're going to get the speed directly by looking at this photo gate. Okay, so I have a photo gate right on here, a little fin that passes through this photo gate and gives us an instantaneous speed just before it hits. So let's start. I'm going to start at position 100. We're going to do one trial per. So there we are at 100. Release, passes through, and our speed is 129.8. Okay, so let's do our next one. We're going to go to 110. Oops. And the speed was 135.1. Okay, now let's go to 120. And again, choose the position that comes closest to your prediction. And that's, oh, that didn't quite work out. I don't know why I recorded 52, so let's do that again. We'll attribute that to a glitch. Let's try 120 again. Okay, so it's going 140.8, so we're getting closer. Reset. Hard to do this with just two hands. All right, we're at 130. And 147.0. Okay, let's go to 140. Okay, 153.8. So we're past our speed. Okay, let's go to 150. $158.7. We go to 160. $163.9. And I'll do one more. I just lost my pen. We'll do 170. Bear with me. I don't want to turn this off because it just makes uploading it more of a pain. Alright, so let's make sure I reset it. I did not. And let's release it from 170. Alright, and we got 166.6. So hopefully your predictions fell between 100 and 170. Now I'll let you calculate, or you have the speed, I'll let you calculate percent differences and then discuss why you may, or how far you were off and why that might have been. Alright, so if you have any questions, make sure you ask.